Okay, we're live. Hi, this is Justine Diamond, and we are here with the Enable Community Foundation Interns for their roundtable, where they get to talk about what they've done this week and how things are going and what else they've been up to. So we're going to start with Tricia at Marymount.
Hi everyone, again I'm Tricia. I'm over at Marymount in Arlington, Virginia. We're kind of close to DC. I am going to screen share for my update. Okay, sorry, it's taking me a second. Okay, can everybody see my screen?
We can.
Okay, great. So this is just another weekly update. So before I begin, we went to an event this week, or last week, excuse me, which I'll tell you more about. But that delayed a bit of our testing. So in the beginning of the week, we just continued to print some pieces as needed. A couple things had been disorganized, so we kind of got everything laid out where we needed it to be, kind of got a plan of what needed to be finished, and also the process of rewiring things had begun again. And so that took us up to kind of date. I've got almost all of our parts needed. We're still looking for a few pieces here and there. This isn't the completely updated spreadsheet, but you kind of get the general idea of how it's running. The biggest parts we need were just the new tensioners, because we got to make sure it's a uniform system. We're also trying to print some of the whipple trees, so that is kind of that. But for an update about our plan for what we're going to be doing, we're going to be doing functionality testing here in our lab. So someone suggested earlier to monitor the wear and tear throughout testing, and I wanted to make sure to put that on our list, because that was a kind of a clever thing to point out, and something that I didn't really think about myself. So again, we're taking suggestions, and we're really happy to hear them. Our first test that we're going to be running is that therapeutic grip and surface area difference. That means that we are going to be putting the various levels of therapy in the hands, having the hands close around those so we can get a nice grip pattern, and then we're going to be trying to measure the difference in the surface area through the use of photographs and some measurements as well. Then we're going to move on to other functionality testing, like gripping mugs, plates, bowls, just basic everyday objects that you and I would need to do. We're going to see if they can hold empty and full plastic water bottles, maybe cans. See if they can carry pitchers, because that's kind of a unique positioning of the hand that's got some ulnar and radial deviation involved, which was brought up in the MedStar event that we went to. We're going to see if they can throw balls, some of those soft balls you use like in the pool. You know, you kind of squish them out and they get soft again after they're emptied from the water. Some harder balls, maybe lacrosse or tennis balls, and just see what the hands can hold. We're going to see if the objects can be carried for different amounts of time, especially the heavier objects. And then if we can get our hands on some of the adaptive utensils that are used traditionally in therapy, we're going to see if we can see how the hands can use them as is.
I got a question for you.
Sure.
On what you're doing. Can you just go back one slide?
Sure. Okay.
So when you're talking about carrying objects for a length of time, isn't that also going to be a function of somebody getting tired, not so much the hand, but getting tired from keeping, because in order to keep the hands closed, you have to keep your wrist in that position.
Yes, and that actually relates to what I was going to talk about next. That's a great question. Is it all right if I change the slide?
Yeah, that's fine. Go ahead.
Great. So we're talking about changing in the wiring. So we went to the MedStar Institute for Innovation in Georgetown, and that paired us up with Peter Binkley, who was absolutely wonderful. It was great to be able to sit down for such a long time and just hear his experience with Enable, but also all of his innovations. And so we were just chatting, he and I, and we were talking about how we see a lot of people kind of torquing their body around to get the hand closed and to pick it up, and it just doesn't look comfortable. I've tried it. It's not good for your back. And so we realized if we can maybe wire the hands instead of putting them at the 30 degrees like they're supposed to be wired at as of right now, we're going to see if we wire them at 45 degrees. And we think this may help with the potential for carpal tunnel syndrome, any additional strain. It puts the hand in a more neutral position. And I can demonstrate once I turn my webcam back on, that takes the hand it puts the hand farther back in that flexed position, but I put my hand in one of the hands, and I found it to be comfortable, and I don't have any serious flexibility in my wrists. And then also hopefully it would bring that closed hand position to a more neutral wrist position. So again, I'll show you all that on my webcam with my own hands in a minute. But we hoped that can kind of offset some of those issues we've seen, as well as just make people more comfortable. So if that means that people can hold objects for longer periods of time, if we wire them differently, then that would take care of some of our questions about functionality and kind of length of time. We also think this may increase the grip strength of the hands. And then we also had the chance to look at Peter's Osprey hands that were fully assembled, and those are just beautiful hands. And Peter is so incredibly creative and crafty with what he does, and I was just amazed with all the work he had done in those hands. And so we tested the Osprey hand on that blood pressure cuff. We wrapped it around that rod, and you just simply squeeze it. And we found that the Osprey hands actually had about 3 times as much strength as the Raptor or Raptor Reloaded, or Phoenix hands. We were able, if you see the photo here, Jordan from Born Just Right, she actually just came up and squeezed the cuff, and so we kind of figure between a 9 and 10-year-old child, we can get about 120 to 140 millimeters of mercury, and so the Ospreys nor the Phoenixes can meet that. But we were hopeful with the Osprey hand, just a very kind of gross measurement. And so we really like the design of the hands as well as the cabling that is used in the Ospreys. So we were really busy representing Enable in Georgetown this week, so that gave us a great chance to examine some of the fully functional Osprey hands as well as those adaptations. And all the adaptations, at least when I took measurements, seemed to be on par with each other. I was pretty consistent. Again, if anybody wants to add functional tests to our list, please let us know. We're still finalizing that. I might have a few more that I'm going to add to the list. But hopefully by this time next week, we're going to have a compilation of all of our therapeutic testing ready to go. So I'll hopefully show you some of those photos and talk about more of those results. If anybody has any questions, please go ahead and ask me, or send me your questions on Google+. But yeah, that's kind of all I have for an update right now.
Oh, so that sounds really good. It sounds like you guys, even with MedStar, got quite a lot done, and that going to MedStar may have informed some of what you're doing.
Yeah, it really did. It was just helpful to have assembled hands ready to go, and just to compare them against ours, the design. It was a really great way to compare pretty easily, and Peter was able to answer any questions I had. And again, we came up with that rewiring altogether. But what I mentioned is that if the hands are kind of set back like this, if we push them back to be sitting like this naturally, and then when the hand gets closed, it'll go from this open position to when it's in that neutral position, the hand will be closed instead of being closed down here. Does that make sense?
That makes a lot of sense.
So we're hoping to change that. I think that we might see more strength just because it's going to put that hand in that neutral, comfortable position instead of torquing the wrist. And so we'll let you know what we see with that. But I think that was the biggest revelation we had this week. It's kind of amazing what you can do when you have other community members around, especially ones that have expertise in design. So I was very grateful to have us enable a representation that we needed to do, because it brought a lot of insight to us.
Very good. Does anybody have anything else for Tricia? Oh. Chris, did you say something? Because we can't hear you.
No.
Oh, okay. Okay, now I can hear you now. I thought you said something. I thought I saw your mouth moving. No, that's great. Do me a favor, Tricia, the presentations that you've done, if you want to put those either in the sandbox so that people can see them if they want to, that would be really good.
Okay, sure. I'll make a note to try and put that up there.
That would be great. If you have any problems or issues with it, let me know, and I'll make sure all the permissions are correct.
All right, will do.
So then we've got Akil and Chris next.
All right. So our week, we don't have a cool presentation. Sorry.
That's okay.
But our week has basically been focused on 2 different things. Continuing to print the OwlFlex hands that Akil designed with help last year, and also trying to work on developing our testing rig. The OwlFlex hands were slowly printing. We're limited by one printer, and the NinjaFlex is slow, and the printer kind of had some issues this week. But we've got one new hand that we're almost done with that is twice the infill percentage, so we're hoping it's a little bit stiffer and easier to pick things up with. We are working on trying to develop a good way to tension those that's very standardized. So we've got a couple of new knots that we've been working on, a lot of watching fishing videos, which is kind of fun. But so there's that, and then we also are now working on the testing rig. We're having a lot of problems trying to figure out if one of the components is functional. You want to talk about that a little bit?
Yeah, sure.
It's kind of a big problem.
So it's called a multiplexer, and it's the basic purpose is to switch between different analog inputs, and then basically forward one channel as an output. And in theory, it should. In theory, it should work as a switch where plugging one thing to one analog input, that shouldn't affect the reading you get at like the second adjacent input. However, we are getting what's called a leakage, which is where a signal that's plugged into one input is affecting the signals at the other inputs. Right. And so we're trying to figure out why that's being. We're trying to understand why that's happening. And so just doing some debugging there.
And the confusing part is that depending on which test we do, we either find that there is leakage and that the voltage we apply to one channel carries over to adjacent channels, or sometimes even all of them, and sometimes it doesn't. So we don't know if the actual component is broken, or if we just aren't using the right tests, or if we just fundamentally don't really understand what's going on. So that's been about all week. That's pretty much what we've been focusing on. We think we finally found a way to test it where we had been using Arduino code to do it all, and the code would basically tell the multiplexer which channel to read from.
Right.
Now we are using a multimeter to check directly, so we kind of eliminate the possibility that the code itself was messed up. I was working on that for a couple hours today, and it was.
Are you getting similar responses?
Yes and no. So it was reading really well for a while, and we were getting these great answers and thought everything was going to work out, and then all of a sudden the reading started changing, even for channels that we'd already checked. So it's like halfway through the test, something weird happened, and so we stopped everything, rewired the entire circuit to make sure we didn't, unwire something, and it gave the same weird readings. So we don't really know what's going on there. Yeah, we're kind of at a loss, to be honest.
I'm not sure.
Yeah.
What to suggest?
This is Andreas over here with Garrett.
Yeah, Andreas.
How many channels is your multiplexer?
16.
16 channels.
Okay. And are you're using all 16?
No.
Well, yes.
Not right now.
While we're doing the tests, we have 15 grounded and 1 wired.
Okay. Okay. Yeah. My next question was going to be about your grounding setup. Everything's on the same ground plane. Nothing's floating.
Right. Yeah, nothing should be floating.
Okay, and you're definitely using more sensors than you have analog in-outs for the Arduino?
Yes. When we do, so right now it's actually just hooked up. The multiplexers are running on their own circuit, not on the rig at all. We took it off because the rig is kind of complicated and we didn't want to mess with the entire circuit. But when we use the full circuit, it's 20 sensors, and there's only room for I think once you plug all of the other things that we need to in, there's only room for 5 or 6 pins.
Mm-hmm. Okay, yeah, that makes sense.
Yeah, so
20
actually, Andreas, do you have a good way to debug multiplexers?
I'd have to take a look at the specific. Are you guys using something from like SparkFun or DigiKey?
SparkFun.
Yeah, SparkFun. We're using the standard one almost. Yeah.
Yeah, if you guys could maybe shoot me a note with what your some information about how you have your multiplexer currently wired up, and then maybe the the application note or data sheet that comes with that that particular multiplexer, I'll take a look.
For sure.
Okay, great. Thanks, man. Yeah, that's
Appreciate
awesome.
it.
Thank you.
All right. And then that.
If you send me a copy of that too, I'll throw it by JD and see if he's got any suggestions for you.
Cool, thanks.
Awesome, thank you.
He may. Do you guys have anything about? I know you're working on reverse stringing, but
Right.
do you have anything to add to what Tricia was saying about changing the angle? Do you have any thoughts on that at all? Just out of curiosity.
I mean, aside, I think it's a great idea. I don't have any like informed opinion about it, but
Okay, that's fun. I was just curious because I know you guys have done a lot of work on stuff that
We
falls
usually
around that.
So just based on testing in the past, we've noticed that we've been able to tension the hands, and at least if you tension it between like 30 degrees, so like if this is like straight, right, and between this, which looks like 30 degrees, and like a 30 degrees upward, that's when they have like at least like what looks like normal motion. But Trisha's idea about 45 degrees may be something that like we should look at as well. We're not quite sure if it would apply in the same idea because we have our hands going downwards in the resting position, whereas I think the regular Enable hands would be going slightly upwards in the resting position. So that.
Oops, everything is frozen.
You guys lagged out a little bit there, I think.
Yep, we lost you for a second.
Oh, okay.
Yeah, go ahead and say what you said.
Yeah, so I was just saying that like because the way that we're tensioning it is flipped, the like optimum angle for tensioning it may be a bit more different than the way that like Enable hands are currently tensioned. So I think we just have to play around with that to see what the optimum is.
Yeah, I'd be curious to see if see how that works with a system that is reverse wired. So.
Right. Yeah, we'll definitely.
The other thing with knots, have you guys looked at all at crimps? Because I know a lot of people use crimps instead of knots.
We haven't actually looked into crimps now.
But we will.
There you go. There's another suggestion.
Yeah, talk to a Boy Scout. Talk to an Eagle Scout.
Yeah, that's what
You just emailed someone who's really good at knot. Yeah,
he goes fishing a lot, so hopefully he can help us out.
I was gonna say
you need a fly fisher, right? They tie a lot of knots.
If you guys can drop your circuits and setup for the multiplexer in the shared Dropbox, then I'll take a look too. Just those are the kinds of things that you can share, and just shoot us an email throughout the week, and we'll be able to take a look at it anytime and maybe eliminate some of the weekly setbacks.
Cool.
Oh, thank you. Yeah.
Yeah, it'd be great.
That'd be
we'll
great.
send you
Thank
guys
you.
the circuit.
Okay.
Oh, awesome.
Okay.
Thank you.
Does anybody have anything else for Chris and Akil?
Have you guys tried the mono non-slip knot?
The what?
It's called a mono non-slip
Mono
knot.
non-slip. Okay, let's write all this down.
I have a link to a really good GIF of it because that's what we started using on the Phoenix hands.
Okay. We've been using, right now what we're using is basically 3 slip knots. One at the top of the finger, which works really well. It hides the knot and it is really stable. And then towards the bottom of the gauntlet, that's kind of where we're having more trouble. So right now what we do is like a slip knot and then another slip knot next to that, and the two together seem to work fairly well, but they're not adjustable. So you have to get the tension right the first time, which is a pain and takes a while.
Yeah.
So yeah, mono non-slip.
Mono non-slip, yeah.
Do we have a pen?
No, we
We
don't.
didn't bring a pen.
It's okay.
Well, I can always make a note on the agenda.
That would be great. Yeah, thank you.
Mono, I'm writing it down. Mono non-slip. Okay, filament. And Dr. Bubar has put up that he'll put because he's having trouble with his audio, he'll put a paper in the sandbox about natural wrist flexion and extension so we can make sure that the wire angles are at realistic values too. He says, I recall up to about 50 degrees is considered comfortable and reasonable. So, okay. Do we want to move on to Jessica?
Sure.
You good?
Yep. Okay, so this week I've basically just been making new designs, scrapping them when I figured that didn't work, making new designs, scrapping them, and trying to land on one that I believe in this time and really think is going to work. And so if you remember from last week, I said that I was splitting into 3 different parts. So you're going to have the attachment and then the forearm piece and then also bicep piece. But after numerous iterations this week, I decided to combine the forearm piece with the actual attachment piece and kind of eliminate it a little bit, try and simplify things. So I'm going to show you guys the design real quick, but if you can just imagine, this is like an attachment, a sample attachment. So you've got PVC here, and then just whatever 3D printed attachment you want on the end. And so really simple. And this is what we used to use with it, where you had to have an L slot going in and then turning. But I'm trying to eliminate this piece. So let me do a screen share. Okay, you guys can see me?
Yep.
Okay, so I'm splitting it into two pieces here. So you've got your basic bicep cuff right here, which is not too changed. The only thing that's changed about it is this little grid system just to make it more aesthetically pleasing. This V, so it doesn't interfere with the elbow. And then these two pegs up here. And the pegs are supposed to be part of the elbow joint. So if you can see, there's corresponding holes right here. So this is the forearm piece, the one that I have highlighted. And so there are holes going through it, and then there's two pegs right here. So the idea is once you thermoform this, it'll just slide right onto there, and then I can see if there's too much wiggle room, if I need to put some kind of cap on top of it to keep it there. But as far as the forearm piece, which is the one, again, I have highlighted here, I was trying to emulate more the, unlimited arm and how it's kind of twisted in its design. So it's not so much the spiral I was going for last week, but it's a more subdued version of the spiral. So this can be on the underside of the arm here, and then the residual limb is just going through and stopping wherever it's going to stop right here. And so it's getting like conical at the end and sort of tapered. So it's getting a nice long look to it. And then towards the end here, this right piece that I have with my mouse, it's going to wrap around to the dimension of a 1-inch PVC, and it has all these holes in it. And so the idea is that we'll drill holes in the PVC also, and so you can change the degree. And then these holes ascending down are so that no matter where the residual ends, you can kind of put it into your comfort level and also get a little bit more stability, hopefully. And then just changing the way we use the Velcro so that it's more like a shoelace Velcro. Instead of 4 pieces of Velcro separately, it'd be one long piece that's kind of woven through. Sort of like those belts that have 2 clasps on them, and you put it through both clasps and then pull back with one hand. It hopefully would be something like that. So that is printing tomorrow because the printers that I normally use that are in the library just got shut down because there's too many particles in the air. And so now I'm transferring all the prints over to the engineering building printing lab, and they'll be on there tomorrow.
Okay. Wow. So the Velcro, instead of individual straps for each one, it's going to be one long piece of Velcro, and then does that have a buckle on it, or?
Yeah, there would be a buckle on it too.
Okay.
Yeah.
That makes sense. Does anybody have anything else for Jessica?
Yeah.
Hey, Jessica. Andreas. I was just curious. Did you design all that in Tinkercad, or were you just importing from another tool?
That's in SolidWorks, but I was afraid that if I screen shared with SolidWorks, it might crash my computer, and so.
Yeah, that makes sense. That's pretty clever. Okay, cool. I was like, wow.
Yeah, I'm printing tomorrow, so if you have any changes you guys think I should make, anything that's whether aesthetic or functional, I can make them now.
Okay, I'd be a little nervous about those posts for standing up out of the prints on the elbow cuff or the tricep cuff.
Yeah.
Just getting sheared off, but that's the one thing I'd be consider changing.
Okay. Yeah, another option for that would be to eliminate the post and just use a simple like nut and bolt. But like we were talking about last week with parametricizing things and keeping holes the same size, I thought it'd be easier to try something that's 3D printed, like a 3D printed clasp for the first time.
Nice.
So I'm just going to put Andreas on the spot because Jessica, was there something in particular you had reached out to him about?
No, I sent him a message a couple days ago before I started on this design. I was just curious if he had any thoughts as to how to get a good functional thermoformable piece.
Okay, so I think we're all good then.
Well, yeah, hopefully. We'll see tomorrow once I thermoform it.
Yeah, feel free to shoot me an email or reach out on Google+, and we can definitely set up some time to talk more about thermoforming.
Yeah, that'd be awesome.
Cool.
Okay, and then last but not least, today we've got Garrett, who's new to our program. He's working with Andreas out at Autodesk. So, hi Garrett, welcome to our little circle.
Hi, Garrett.
Hello.
Everyone here is really helpful. One thing that's been great about the interns and the projects this year is they all dovetail each other really nicely, and everybody's been able to help each other and such. So feel free to dive right in. I've set up, as you probably have access to now, a sandbox folder where you can just put up files or put up stuff you have questions about and let people know, and everyone is happy to help.
Okay, thank you.
Great. Do you want to tell us about your project?
Okay, so what I've been working on most of the time is modeling most of the STL files for the Phoenix hand in Fusion, and then labeling the parametrics for all the parts so it's easier to size up and size down. And then Andreas is going to use these files to put into LimForge so that people can have like a lookup table for all the sizes. So, yeah.
That's going to be really, really good.
Yeah, so Garrett's cutting his teeth, taking the Phoenix over the finish line on the kind of parametric conversion, and has demonstrated that he's a ridiculously proficient modeler in Fusion. So I think the next step that's going to be kind of the big summer project is going to be designing some new device elements around the LimForge infrastructure, so really leveraging that deep parametric control to leverage more off-the-shelf fasteners, more modularity with consistent, or I should say persistent interfaces, and really starting to get more nuanced with the sizing. So some pretty exciting stuff coming down the pipe.
Oh, that would be pretty awesome, because I know with certainly with the Phoenix, when we've printed really large sizes for demo hands, we end up with all sorts of problems because of the non-parametric aspect of it. So that's going to be really, really awesome, Garrett. It's going to make people in this house very happy.
All right, that's good. Yeah. All right.
Yeah, we've got a big box of show and tell. We've got a lot of physical prototypes that unfortunately we won't be able to show today because our webcam isn't working. So we'll do updates from drivers for next week, and by then we'll have some more prototypes to share.
Okay, that'll be great. That'll be awesome.
Yeah.
Okay. Does anybody have anything else? Any other problems or anything that came up that we haven't already gone over?
Not here.
Okay, well, thank you all very much. We'll be back with all the interns next week, and we'll see where everybody is at. Thanks a lot. Bye-bye.